Hey guys, I'm back to do our second ester lab, and in this experiment, acetylsalicylic acid, or aspirin, is going to be synthesized through the acid-catalyzed esterification of acetic anhydride and salicylic acid. All right, to start, what you guys can see is that I have my setup here. All right, I have a hot water bath that I'm just beginning. In the back there you can see I have my Buchner funnel apparatus, and then here are my chemicals and my balance. Okay. In the first step, what I'm going to do is I'm going to add 1 gram of salicylic acid, and I'm going to add 1.08 grams of acetic anhydride into my small reaction vial. Put this in here, tare it. This opening is very small. Let's see how I do with this. 1 gram. Let's see. Okay. All right. 1 gram is going to be quite a bit, I guess. I'm at 0.5 grams. Point 6 grams. Point 8 grams. 0.87 grams. 0.99 grams. I'm going to call it a day at 0.99 grams, and I can record that in my data table. Next, what I'm going to add is 1 milliliter of my acetic anhydride. It has a density of 1.08 grams per mil. So I'm going to be adding 1.08 grams of acetic anhydride to my test tube, to my reaction vial. Acetic anhydride. I'll tare this. At 1 gram, I'm going to try to add a drop at a time. And I have here 1.10 grams. So I'm going to go ahead and record that in my data table. Finally, I'm going to add 5 drops of my acid catalyst, sulfuric acid. Cap my reaction valve tightly. Shake it. Okay. Tighten it one last time. Now I'm going to add my copper wire handle and set it up for my 10-minute incubation period. During my 10-minute incubation period, I am going to be getting things ready. I have an ice water situation that needs to be set up. Okay, here we go. Here we go. Okay, one more time. And so that you guys can see. In we go. All right. I'll see you guys in 10 minutes. Alrighty guys, I'm back. It's been 10 minutes plus a minute for this to cool on the desktop. So I'll undo my copper handle now. And what my instructions are telling me to do is to carefully pour the contents of my reaction vial here into the test tube, which contains the ice water setup. Here's my test tube. I've had my distilled water on ice. Test tube, reaction vial. And hopefully what you can see is that I have the formation of white crystals. They're asking me now to rinse my reaction vial with some cold water. So we'll do that. Okay. All right. Now I'm asked to cap the test tube and shake. I don't even really need to do that though. And I don't like shaking these anyway, so I'll just mix it. All right, and now I'll sit it in my ice water bath for about 5 to 10 minutes more. And when I come back, we'll be ready to filter using the Buchner funnel. Alright guys, I'm back here to do my filtration. I've weighed my filter paper ahead of time. It's 0.63 grams. So I'll slowly add the crystals here. Alright, now I'm going to wash them. Do this. Come on.
That's 161, 143, 119, 109, 153, 113.
It would help if I added it.
Please dismiss and enter to the auditorium. That's 161, 143, 119, 109, 153, 113, and 108. Please exit the auditorium.
I'm not really getting them to come out here. All right. I'm going to try to use my old friend here, the rubber policeman, to get this out. Okay. If I can loosen this up now and maybe add a significant amount of water, I think I should be able to get most of this.
138, 106, 155, 110, 158,
There we go. Better.
151. Please dismiss and exit the auditorium.
Need a little more here.
138, 106, 155, 110, 158, 160, and 151. Please dismiss via the natatorium.
Try and get my percent yield as much as I can, but it's not going to be perfect. Okay, one last rinse.
That's 105, 136, 117, 102,
This is as good as it's going to get.
167, and 111. Please dismiss and exit via the auditorium. That's 105, 136, 117, 102, 137, 167, and 111. Please exit via the auditorium.
Okay. Now what I have here in my funnel is my crude acetylsalicylic acid. I'm going to let this dry overnight and weigh it. I'll recrystallize it tomorrow and attempt at a boiling point. I'm sorry, a melting point. Alrighty guys, I'm here and unfortunately I have a class, so I'm going to have to narrate this instead of talking to the camera. My crude product has dried overnight, and now I need to weigh and determine the mass of crude product that I have. I weigh it and I determine that I have a total mass of 1.10 grams, which I record in my data table. The mass of my filter paper alone is 0.63 grams. Next, what I need to do is begin my recrystallization process. I've made my 25% ethanol. I have my large reaction vial, and I've determined its mass. Now to my large reaction vial, what I'll be adding is as much of my crude product as possible. I need to determine the mass of the product that I'm adding simply because I need to determine the amount of 25% ethanol that I'm going to recrystallize it in. I start by adding the large crystals, and they're not really adding up to any measurable mass on my balance. So eventually what I have to do is try to create a cone out of my filter paper and try to add as much of my product as I can to my large reaction vial. This process is going to take a minute or two. Still not having much luck in terms of getting a measurable mass on my balance, so I continue to try to add as much as the crude product as I can. Eventually, I do see a change in my balance, but that change is nothing compared to the initial mass of crude product that I had. Based on the mass of the crude product and the filter paper, and then the mass of the filter paper by itself, I estimated that I had recovered about 0.45 grams of my crude product. And at this point, my balance is really only measuring 0.07 grams of crude product, despite the fact that I've added almost everything off of my filter paper. So in order to check my numbers, I wrote down what I had off my balance, but I reweigh my filter paper now. And when I reweigh my filter paper, I see that the mass is now 0.7 grams. So remember, originally its mass was 1.1 grams. I write that down, and I assume that I've added about 0.4 grams of my crude product to my reaction vial. The procedure says to use 1 to 2 milliliters of 25% ethanol to recrystallize for every 0.1 grams of crude product in order to recrystallize it. Estimating that I had about 4 grams of crude product, I added about 8 milliliters of my 25% ethanol solution to my reaction vial. Once I've added my 8 milliliters of the 25% ethanol solution, I tightly cap the reaction vial, invert it a few times, and then attach my copper wire handle so that I can heat this mixture in order to get my crude product to dissolve. Now that my copper wire handle is set up, I add it to the hot water bath, and I'll set a timer for a few minutes in order for it to heat up to the appropriate temperature. I'll see you in 3 minutes. My timer's going off, and I'm back. It's time for me to remove this from the hot water bath, and I find that it's quite hot. You can see that everything has dissolved. What I'd like to do is mix it thoroughly, but it's too hot to handle. I use a paper towel. You can't see it out of the screen. I'll bring it into the screen in a minute, but I'm trying to hold this and invert my vial several times in order to ensure thorough mixing. Now it's time that I let my vial cool on my desktop, so I'll set the timer for another few minutes. See you then. I'm back as my timer is going off. Now it's time to transfer my vial to my ice water bath. I'll tighten the cap one last time, and I'll add it to my ice water bath to incubate. The procedure says to let it sit for several minutes, so I'll set my timer for 10 minutes, and I'll check back with you then. Hey guys, I'm back, and now I can talk because I don't have any students. If only my watch would stop. So take a peeky. Look at this. Pretty awesome, right? Now the challenge is going to be for me to get this out of my reaction vial and into my funnel. So here, we're going to be doing this again. All right. So to start, I have a new piece of filter paper. And I've measured the mass of my filter paper to be 0.62 grams. I'm going to go ahead and I'm going to put it in my funnel. I have some water, which I put on ice. I'm going to be using that to rinse. And I think I'm going to try to maybe zoom out a little bit so that you can see a little bit more of what I'm doing while I'm doing it. Okay. Let's see, I have a pipetter, but like I said, I think this is going to be a bit of a hardship. So here we go. I got to really get this in there. Okay. Turn my water on high. The first thing that I'm going to do is wet my filter paper with cold water. And hopefully I'm going to get some form of a suction here. This is so hard to do. Alright, I see some water starting to come through. Let's try a little more here. Let's see what I can get. Here we go. Alright, I think it looks pretty good in here. So now again, what I'm going to try and do, being the opposite word, is to get my product out of this reaction vial and into my filter. This is not... This does not look good, as I feel like it just went straight through my filter paper. Not good. Alright, I'm going to turn this off. This was not what I wanted to happen. I'm going to get a small beaker and I'm going to try and filter this again. The good news is I still have some crude product, so I could maybe try to do a melting point test with my crude product. But what you can see is a lot of white stuff in the bottom of my flask. It's really not good. So let's see what happens here. Try this again. Maybe I can be a little bit more careful this time. Okay. I also wonder if the problem is that I did not let it crystallize long enough, even though it was white. Maybe it's not fully as solid. Because as I do this again, and even though I'm doing it more carefully, I don't know if more carefully is even a word. Okay. You can see I still have stuff here. Looks like I have some solid in here. So what I'm going to do, I'm going to do this. I'm going to sit this in the ice water bath for a little bit longer, and then I'll come back and I'll filter this again. Alrighty guys, I'm back and I got it. And the way that I got it is by I thought that the filter would be cold enough by rinsing it with cold water, but what I actually did was let some ice cubes sit on it. And now what I have is a collection of some crystals here on my filter paper, which I think is going to be hard for you, but maybe not because I can see them. All right. And then maybe if I do it, I think you can start to see. I hold it off to the side. You can start to see some crystals on it. So now I'm going to let it dry, and I'm going to do my melting point test. Alrighty guys, personal diary time. So as you can see here, I have tried twice to do the melting point test, and twice it did not work. So what happened really was that it melted over a period of time. I'm going to try and sit down and talk to the camera. It's going to be extreme close-up. Extreme close-up. There it is. There we go. All right. So it melted over a period of time. Not only did it melt over a long period of time, which suggests that it's impure, it did not melt at the right temperature. So maybe at like 120 degrees. I can't even, it was hard for me to even tell because I was distracted and distraught by how soon it started to melt. And so if you wanted to talk in terms of error and why that happened, my best guess would be that because when I was filtering my recrystallized product, it passed through the filter twice into my flask, and my flask was not clean when I started that. So I had used that flask earlier in the lab to filter my crude product. So there was a mixture of stuff in there. And so I, again, tried to recrystallize within that mixture, but what ends up happening then is stuff gets incorporated and the crystals are now not pure anymore. So again, melted over a range. Not only did it melt over a range, but it really didn't even melt at the right temperature. So again, it melted over a range because it was impure. It didn't melt at the right temperature. I mean, I guess that could be due to its impurity, but I also, again, think it's the struggle with the oil bath. So this oil temperature is not distributed evenly, if that even makes sense. So it's very hard to have a uniform temperature in this type of a bath. Also, it is very difficult to control how that temperature is changing. So if you're measuring a boiling point or if you're measuring a melting point, I think I used boiling point in there and I meant to use melting point, but regardless, I think you understand what I'm saying. When you're measuring those types of things, you really need to have a slow, controlled increase in temperature for a melting point or decrease in temperature for a boiling point. And if it's not slow and controlled, changing too quickly, then you will not see your substance melt or boil at the appropriate temperature. All right, guys, that's it for this lab. We'll see you next time.